Hi everyone, we're going to solve this trig equation, give a general formula for the solutions, and list all solutions between negative pi and pi. The first thing I would do on this one is just go ahead and divide both sides by 2. So you get cosine of 3 theta equals negative square root of 2 divided by 2. So I'll write that again here. Cosine of 3 theta equals negative square root of 2 over 2. So what I'm going to do, this is my primary angle. I'm going to make a secondary angle here and just solve for alpha here and then deal with this later. So where does cosine of alpha equals negative square root of 3 over 2? We know cosine is negative in quadrant 2 and 3. So that's going to be at 3 pi over 4 and 5 pi over 4. But my alpha really is 3 theta. So what I'm going to set this to, I'm going to set 3 theta equal 3 pi over 4. And then I'm going to add the period 2 pi. I'm going to just put the k for the number of times I have to keep adding the 2 pi. And then for this one, I'm going to do the same thing. 3 theta equals 5 pi over 4 plus your period of cosine is 2 pi and k is the number of times you're going to keep adding 2 pi. Now let's solve for theta. So theta equals, if you multiply everything through by 1/3 here, you're going to get theta equals 3 pi over 12 plus 2 pi k over 3. And same thing here, multiply everything through by 1/3, and you're going to get theta equals 5 pi over 12 plus 2 pi k divided by 3. Alright, now, so these are our general formulas. Perhaps this one, it's better to write the general formula as pi over 4 plus 2 pi k over 3. So these are your general formulas. Now we have to solve all the way from negative pi to pi. So I'm going to keep adding 2 pi 3 to my solutions to get there. I'm going to go back and use this one to do that. So basically, if k is 0, we're not adding anything. Our solutions are 3 pi over 12. And to add 3 pi over 12 plus 2 pi k, I need to have a common denominator. So to have a common denominator here, this is going to be 8 pi, and then you would have k. And let's just don't worry about the k right now, and let's just add these up. So if I add 3 pi plus 8 pi, that would be if k is 1. That would be 11 pi over 12. And since I'm dealing with 12 as my denominator, let's just write the pi's as negative 12 pi over 12 and 12 pi over 12, because that will get you can't go higher than that. That still is pi. So I know I can't add another 8 pi over 12 because it would be too big. It would be over this. But I can subtract it. So let's subtract here, and that would give us negative 5 pi over 12. And if I subtract another 8 pi over 12, that's going to be negative 13 pi over 12, which won't fit in our domain. So we're not going to subtract that. So we're done with that part. Now let's deal with this side. I'm going to have 5 pi over 12 plus 8 pi over 12. And that equals 13 pi over 12, which is too big, because we only can go to 12 pi over 12. So I'm going to cross that one out. And let's try minus. If I do minus here, so because we have to go negative, that would be k is negative 1. So that would be negative, that would be k is negative 1. I'm not going to write it, it's just confusing. And that's going to give you negative 3 pi over 12. And that works. So we're going to write 5 minus 8 is negative 3, so that's negative 3 pi over 12. And if we subtract another 8 pi over 12, that would be k, that would be k equals negative 2. If we subtract it again, we're going to get negative 11 pi over 12. So that would be all your solutions. Now once you get all that, if you want to simplify this is fine. But if you want to clean up these, this would be 3 pi over 12 is really pi over 4. Then we have 11 pi over 12, negative 5 pi over 12. This one would be negative pi over 4. And we have negative 11 pi over 12. Oh, and don't forget we have this 5 pi over 12. So 5 pi over 12. This was a long one. So how many solutions did we have? We had 6 solutions. All right. That's it. Thank you. Have a nice day. Bye-bye.